Okay.
Hello again to everyone. So I will present a quality approach of chemical management that I decided to call process approach and continual improvement of chemical management. So I will do a small introduction, the context perimeter, and then internal and external issues, and the process approach and the conclusion. So as you know, when we are talking about chemicals in industry or in the laboratory, the background is really large, wide. We have a used product, emitted products, and really different environments, hazardous environments. And of course, the will is to protect health and safety of employees, to respect, of course, the legal obligation, improving working conditions, and reduce injuries and near miss. So, to compliance with regulatory context in Europe, that I know better, we have the chemical legislation is based on 3 different regulations: REACH, the classification, labeling, and packaging. So REACH it will be through the safety data sheet, and the directive that will speak about the risk assessment on chemical agents. In France, more specifically, we will find it also in the work code, where we will find the chemical risks, the carcinogenic, mutagenic, reprotoxic risk, and other specific risks like asbestos, for example, or silica. And we can have sometimes specific company standards that we must respect, like company occupational hygiene standard or specific restrictions lists. And when we are talking about the context in the laboratory, we might consider injuries and near miss. And for example, in the company where I applied this approach for the first time, it was the chemical risk was in the top 3 of the risk assessment. That's why they really wanted to improve chemical management. So chemicals are everywhere, are in research and development, in manufacturing, in quality control, and even in disposal. And that's why it's really important to consider all the sectors. Another important thing to consider is when we are talking about chemicals, we used to think only in the facility or in the laboratory in which we work. And actually, it's really important to consider also that we are all the time exchanging chemicals with other laboratories, other facilities from the same company or another, with customers, with contractors, and with suppliers. And sometimes they will also come to work in our facility, and we forget that they are also exposing themselves, but our employees too. So it's really important to keep this on the perimeter, and also, of course, the number of chemicals we use, the number of new products, the number of users, external or internal, number of teams. It's really important not to forget the cleaning companies, the technical service, and the contractors too. So with this approach, it's really interesting to do a SWOT, to measure strengths, weakness, opportunities, and threats. And it's important not to forget that in the threats we can have environmental issues and economic stakes. For example, in France, in 2019, the average cost of permanent disability in chemical industry was really, really high. And that's why it's really important to take, this will help you also to convince the management of the company that chemical risk is important too. You can even do a 5W, and this is really important, mostly the who. because when you have a project, it's really important to define a work team, because alone you won't be able to go so far. So create a multi-field work team will help you. It's really important to consider, if you can, the physician or doctor, medical doctor, the users, the facility manager, if you can, and of course the health and environmental manager. When you are doing the what is to create or improve chemical management, when where is in the laboratory, and when this we'll talk a little bit later, but it can be really long if you want to do a really good improvement on chemical management, between 12 or 18 months or more. So I had the idea to apply this quality approach to chemical management when I saw the definition of the processus definition that say that this is a set of interacting activities that use input information to produce a result. When we look at the chemical steps, actually it's an interacting, there are interacting activities. So it's do inventory, assess the risk, eliminate, replace, that's what Ken said earlier, measure, monitor, form, and inform. So if there is the same order than in a processus, we can define a cartography, a processus cartography. And the advantage of doing this is that you can really see that if you want this to work, you must consider the risk and opportunities. You must define and manage the goals, the objectives, and that you need, of course, to provide technical, human, and organizational resources. When we are talking about inputs, it will be the regulatory requirements or company. Of course, you can include the near miss or injuries, chemical products, and so on. And when we are talking about outputs, it will be the procedures, the authorization, the measurements that you can do, training, or medical supervision, between others. So it's really important when you have a project to define goals. In my case, what I did, I decided the goal was to provide a framework for management of chemicals, following the general principles of prevention for chemical risks that are defined on the European directive, and to match this with the Plan to Check Act, the Deming Wheel approach. So I just put them inside. And this is really important because mostly when you are in a laboratory, chemicals are arriving all the time. And every time one new chemical arrives, you will have to restart the wheel. You will have to introduce it in the inventory to assess the risk, try to eliminate if it's really complicated, and protect employees and so on. So this is the main goal. Of course, it's important to define specific goals, specific objectives, like apply the approach 100% of chemicals, or train all users, or update medical supervision, and so on. It's up to you to choose the specific objectives that you want to achieve. So when we are talking about objectives, of course, it's important to define indicators, monitoring indicators, like the number of products, number of injuries or near miss, number of safety data sheets that are updated for less than 4 years, and so on. And it's important to choose smart indicators. That means specific, measurable, attainable, relevant, and timely. And in my case, we had the chance to do that with Quarks Safety, that allows us already to have those indicators, personal indicators on the dashboard. So of course, like it is a project, it's important to define all steps and do a Gantt or a planning that can be between 3 to 18 months. It depends on what do you want, how far you want to go, and all the context, of course. So let's start defining all of those steps. So the first steps, the inventory, it goes to with the definition of exposure groups. Like I said at the beginning, you must define all the exposure groups, and it's really important not to forget technical service, cleaning company, and contractors. And then when you are doing the inventory, it's really important to collect the name of the designation of the product, manufacturer, physical states. So those informations, you will find them in the safety data sheets that is mandatory. And in our case, well, again, we had lucky because when you do it with Quarks, the software will take all this information automatically. Something really important when you are doing the inventory is to try to waste old products. Don't enter in the inventory old products, try to eliminate from the beginning. So then we will go to the risk assessment. So if you remember what Ken explained, there is the danger, the product itself, the intrinsic danger, the hazard level, and then the way you use the product. All risk assessment methods, they use the same methodology. They will match both, and they will calculate a residual risk that it can be for inhalation, cutaneous, and you can go further, of course. And but in our case, so you can do it for different groups of the same product. You can have different risk assessments for with different scores, of course. And the parameters you must collect for the risk assessment will be the users, name, frequency, duration, quantity, the process if it's open or closed, the activity, and of course the collective protection equipment or personal protection equipment used. So those is information you will enter in your inventory in your system, and you will be able to calculate the residual risk. Once you did the risk assessment, you will have a different score, and you will have to prioritize. And of course, you will choose always the high risk levels. And then it's really important to do an action plan. And then it's really important not to forget the human, organizational, and technical resource that we spoke earlier in the cartography. So you will cover all the aspects. Human, it will be like training, you will have to do list of the users, the most exposed users, for example. In organizational, it will organize training, organize the rooms, the number of use to train, the approval process, and so on. And when we are talking about technical resources, is about the number of breakdown to be checked, or to create a support, for example, if you want to for the training. So then, if you remember, what's the eliminate and replace? So once you did the risk assessment, you did the prioritization, the first thing to do is try to eliminate. So what I did in my case is that I went to see all teams and all users, and I discussed with them. It's really important to ask them a lot of questions, because they know what they do, why they use those chemicals, and they know the best if there is a possibility to change or to replace. Of course, sometimes you must help them. That's why we have some specific websites or links that will give you information about how to replace some chemicals, for example, CMR. And this first step is really important, because in the real life example that I did, we could pass from 18 to 5 skin risk products, high priority, and from 3 to 0. And related to CMR, we passed from 73 to 42. So just asking employees how can we change, and trying to discuss about to propose something else, it's really important. Of course, you will have still some high priority risk. And for this, it's really important to train about why, what they are using, how they are using, train about the storage techniques, how manipulate chemicals, about how to read the safety data sheets. And really important, inform and train also about the approach you are doing, because this is something I did at the end, and they were really happy about knowing all the approach, the chemical management approach. It's really important not to forget to do training on accidental spill, and to put spill kits everywhere, and checklist to verify, to check periodically. And sometimes even training is not enough, and it's important to measure, to do exposition measurements. Sometimes also it can be mandatory for some chemicals, so you have to do it. And to do biological testing to reinforce medical monitoring. And it's really important to control individual exposure. So those things are things that we could also apply thanks to Quarks safety, to follow the exposition measurements and to do individual exposure from each employee could do it by themselves. And the last step, but the most important actually, is to monitor and improve the system. So this, in our case, we did it in 3 steps. So the first was to implement an effective validation workflow. So that means that when the products arrive, if it's not classified as hazard, the product will be validated automatically. If there is a physical hazard, it will pass to the safety leader. If there is an environmental hazard, it will go to the environmental leader. Sometimes it's the same as the safety leader, but not always. So it will do both. And of course, the local approver, because the local approver must validate that he agreed the user to buy this product. Of course, if there is a health hazard or nanocriterion, we choose in our case, so the product should pass by the occupational doctor, because it's the doctor who can really give his authorization. And if you really want to go further, you can have even a level 4 for new users. If you have a new user for a product that is already validated, you can do a new level that pass only by the doctor and the safety leader. Of course, you can also add restricted list, substances list if you have in your company, or for example, with this for pregnancy women or temporary employees. All of that was also entered into the Quarks safety software, and it allows to have approval data sheets that can be adapted for each user and team, where they will have the most important information about the hazards, and also the comments of the approvals. Something else we applied, and it was really helpful, is that, of course, you have a system, a validation system, but sometimes employees, they buy the product and then they send the validation demand. And the problem with that is that they are using the product before the doctor, for example, gives their authorization. That's why we implement that when the product arrives at the storekeeper checks the status on Quarks. Then if it is accepted, we'll call the user and he will be able to use it. If it's pending or reject, it will go to jail until the product is validated. Or you can also pass through SAP, and in this case, the purchase checks the status on the system. If it's validated, he will place the order. If it's not, he won't place the order. So there were two important things in monitoring and improve the system. The most important the really important thing is also to monthly or every 3 months at least monitor the indicators, because it's really important to follow, to monitor, and also to apply internal audits with a really internal audit plan, where sometimes the audits can be hard because it's always the safety manager that do them, and the idea is not to imply all users. That's why in my case we decided to do a planning with each month one team had to audit another team, and this allows employees to really imply and be engaged with chemical management. So for the conclusion, this approach can really give a significant improvement in chemical management, can help you to achieve 100% of your objectives. It will help to develop the independence of each team, responsibilized for the products introduced on the site, and it will really give a significant reduction in accident at works. Of course, this step automation will really light the system significantly. Thank you very much, and if you have any questions.